In this video, we'll be seeing how to use C STL library to solve any C program or to create programs. So the most important place where STL is used is, I think, for competitive programming. This would be useful who are getting started with STL, and because I'm going to just give a basic introduction on how to use because there are much more functions in STL library. I'll be going through most important ones, and even in most important ones there are few most important functions, so we'll be going through that. And first thing that we need to get started is with vectors. So vectors is like array in normal programming world. So even before that, what I want to do is I want to give you an introduction to how C++ STL library syntax is made. Like, it's quite different when you use C++, right? So STL is quite different from normal C++ programs. So I'll just give a bit of introduction to that, because different containers, so each of them here is a container. So each container has not a completely different syntax, but quite noticeable difference between them. So yeah, let's get started with vectors. So even before that, we need to write our int main. So I'll just tick off this vectors when it's completed. It's like a to-do thing. The basic includes our IO stream, and I will just use the namespace also. To use this STL containers, you need to include them. Like, you can't include them in a single header file. You have to, for each container there is a separate header file. So for vector, I think it's quite straightforward. It's hash include vector. So yeah, that's how we include this. So let me give a bit introduction to vector. Like, in C++, we create arrays by saying a of 100, right? But it is really necessary to give this array a size, right? Like, we need to mention the size of the array, even if we're creating it dynamically by using is equals to new in something like that. I think you need to give the size even if it's dynamic. So the plus point of vector is that it does not need a size. It's just a dynamic array. You can think of that. We need to create a container, or like a variable for this vector. So we do that by first saying the container name, let's say vector, and lesser and greater sign, and between this is what you give the data type of this vector. So if you're going to store int, then you'll be giving int here, and then after and then you continue by giving the vector a name, let's say v. So v is the name. So by saying this, you tell the compiler to create a vector of type int and name it as v. It's similar to saying int v, but instead of int, it's vector of int here. So that's the only difference. Right now the size is 0. So let's add some elements to this vector. So to add, there are two important functions. So one, let me put that in a comment. To insert elements into this vector, you have I think two functions. So one is, they say it as pushback of the element. So you usually do that after this dot. So dot, it's a function, so it's pushback of element. So whatever element you want to push into v, you just say v dot pushback. So in this case, you could do pushback of, let's say, 100. Then this 100 is pushed into the vector v, and if you copy this and paste the line here to confirm the size, and you can see it's 0 and then it's 1. We should have put that in a new line, but the 0 is the first size, and after pushing an element, it's 1. So yeah, we have inserted one element, and to remove that element, you could do v dot pop back. So that just pops you could say the last inserted element into the vector. So even now again, if you run this, you should be getting 0 0, because after inserting we removed it immediately. Let's say I just copy this and I say, let's say I have 4 elements now. So let's verify that I have 4 elements now, and I want to write a for loop to iterate through every element and get the element, I mean just print the element out. So you could just write a for loop here and then just print the elements by saying v of t, but there is a concept called iterators. So it is quite important when I mean if you have to know this if you're using STL containers. So its iterator is nothing but it's a pointer which points to some element inside the container, and you could use that iterator to iterate through the elements in the container, and then you can use them to print or for any other purposes. For example, we have written a simple for loop here to print the elements. Instead of that, we could do that using the iterators. To first initialize a iterator, you have to say vector, which is similar to how we declared a variable, vector int, and then you give this two colons and say iterator, and then you give this iterator a name. Let's say vitr, which is vector iterator. It stands, you could give anything, the name could be anything, and now you could use this to iterate through the elements. So you could instead of writing the same for loop, you could say for vitr is equals to, so we are going from start of that containers, or you could say from start of the vector to the end of the vector. So you could point this pointer, this iterator, to the first element of the vector by saying v dot begin, and vitr is not equals to v dot end, and plus vitr. And by this what we mean is that we start from v dot begin, and until v dot end reaches, we don't stop, and we just loop through every element. And to print that element out, you could just say star vitr. Let's put a space here, and let's see if this works. Let's comment this out. And you can see it works. Sometimes when you're using bigger containers, or it becomes or you could say if you're using a bigger code base, it becomes difficult to declare this iterator every time. So to do that, you can just remove this, and here you could put auto if you want this to be just a temporary variable, or you could say just for the use of the loop, you could say. So that works as well. So that gives a warning because you have we have not run this using a C++11 compiler, but that when you use C++11, it does not give you a warning, but it still works even in previous versions. That's all we need. So yeah, that's how vector works. Similar to pushback, we have another function which is insert. So this insert takes the position where to be inserted, let's say the position, and the element to be inserted. But this position you can't just give it as 1 or 2 or 3. It takes it in a form of the iterator. So what I mean by that is that wherever the iterator is pointing at, there it inserts the element. So it's simple. So we can check that. Let's print it in a new line. So because we are printing this array 2 times, let's just insert a new element at position 2 after this first print. We could do it by saying v dot insert. We could just give a pointer. You could say v dot begin plus 2, and the element to be inserted is 600. So we just insert 600 at position 2, and let's try to run this, and you can see that this has actually inserted at position 3. That's because it starts from this and 2 positions after that, so 1 and 2, we insert it here. So yeah, that works. That's how insert works. There are many other, you could say, functions for vector, but I think this is one of the basics that you need to learn. So let's move on to the next container. Let me make this as done. And iterators, I think we have talked about that. That's similar to all of them. So next is queues. I think if you know how the queue works, then it would be easy, like to know how to use STL to achieve exactly what a queue does. So for that, similar to what we did with vector, we have to include queue. So for queue, we have included that here, queue. And for queue, what we do is similar to vector, which we have done vector of int. We just do, instead of vector, queue of int, and the name of the queue, let's say queue. The name of the queue is queue. So now you can push and you could say pop elements from this queue. So some of the functions that exist are queue.push 1, and that's to push the elements into the queue, and queue.pop removes the element from this queue. So pushing and popping, so these are two basic functions in a queue. And queue.size gives you the size of the queue. So if you pop after this, then the size here would be 1, and pop removes that element from the queue. I mean, to see the front and back elements, you could see using front and queue.back. So with this you can get the front and back elements. What I mean by that is that if the queue is in this structure, then 5 is at whenever we pop, 1 gets popped first, and then 2 gets popped, and then so on. So let's try that. So to print out what's inside a queue, first let's push some elements into this. 1, 5, 2 and 9. So to print this, what the usual technique with queue is to we put a while loop, and we say we also have another function with all containers. Mostly all containers is that queue.empty. So it gives out a boolean value, a true or false value. So if the queue is empty, then it gives a true value. If it's not, it gives a false. I want to run this loop until it's empty. So while it's not empty, run the while loop and just print me what's the front element, and then just pop that front element. So by this it will be like looping through the entire queue. So let's try if this works. So yeah, this works, like 1, 5 and 2 and 9. So that's what it's here. So 0 is from this. We could use this empty for vectors also. I forgot to mention that. So yeah, that's I think basic functions of queue. Next is stacks. So it's really similar to queue, but I think we need to include stack here in order to use stack. So similar to how we have initialized stack queue, we can do that similarly by saying stack of int, let's say s as the name of stack. So to push, so similarly there's a push function and there's a pop function, and instead of front or back in stack we have the top function. So that gives what's at the top of the stack, and we have the size function, so which gives out the size of the stack. So right now let's push similarly 4 elements, and similar to what we did in the queue, like we will give the top element and then we'll pop and pop until the stack's empty. So similar to that, while the stack s dot empty, and if it's not empty, then run this loop and show me what's at the top of this stack, and then just pop that from the stack. So let's run this. You could see there's 19, 3, 4, 1. So it's in the reverse order because that's how the stack works. The next container is sets. So we have to let's include that by saying hash include set is how we include that. So set is something that it's similar to what you have read in maths. Like set is something which has only the unique elements. There would be no duplicate elements in a set. So to initialize that, we just say it's set of int, let's say st for set. So in set we have we don't have push, we have insert, because we insert elements into set, right? So let's insert 1, and let's insert another 1 and 2 and 3. So there are 2 1s here, and let's insert another 2. And also we have similarly we have like set stacks and queues, we have size, we have empty, and also we have an erase functionality. So we can erase any element from this stack, from the set. So we could say 2, that erases element 2 in this set. To print these elements, what we'll be doing is we'll be doing what we have done similar to vector. So we'll be saying for auto iterator is equals to set.begin, iterator not equals to set.end plus iterator, and we'll just do star itr. So this should print what's inside a set. So let's print that. So you could see we have 1, 2 and 3, even though we have inserted 1 2 times and 2 2 times. So now let's try to erase the element 1 and then print this, and that erases the element 1. So this is how set works. So the next, I would not say, like this is not a complete container, but it's just a variable kind of thing. So a pair, so we have to include that here. To include pair, we have to include the utility header. So it exists in utility header. So what pair does is that it has it's like a struct kind of thing. So you could think you could think pair as a structure of this kind, int x and int y. Whenever you create some struct, you have x and y attached with this, right? So you have two variables every time when you create a struct of a. So similar to that, we have pair of data types int comma int and let's say p. So that's how a pair is defined. So what's the specialty of this data structure is that this has two variables, first and second. So this first int is known as first and second int is known as second. So of course, if you want to change or assign the first int, you could say p.first is equals to 2 and p.second is equals to, let's say, 4, and you could just print p.first and p.second. So let's print if this works, and it prints 2 and 4. So yeah, this is quite simple, but you could use this with any kind of container. So for example, let's say you have a stack of type, you can have a stack of type pair of int. So this can be quite complicated, but in competitive programming this would be much helpful. So in this case, when you're inserting into stack, you can't just push one into this, so you have to push a pair into this stack. So in order to push pair, you can't just push 1 or 2 or like that, so you have to make a pair. To do that, you have to make pair of 1, 2. So that makes a pair and pushes into the stack. Let's see if this does give an error. No, yeah, this works. So you have to make a pair into this. So even if one element is missing, I think it would be giving you an error, like because there's it expected a pair but you gave only one argument. So that's how powerful this pair container is. So it's not just for pair, you could combine any container with any other container. One of the most important data structures in C++ is dictionaries. Like in Python or JavaScript, there's dictionaries. So in C++ we have maps and unordered maps. So first, maps. So let's see what maps do. We have to include that first. So let's include map, and similar to what you have known, map takes two, like every dictionary has a key and a value. So even in C++ we do have key and value. So both need to have some data type. So in this case it would be, let's say, internet. It could be any data type. So let's say MP for map. So what this does is that it creates, and this is how we initialize a map. So if you want to map some variable to some other variable, you could just do like this, like just assign the index kind of thing, but usually it's not index. But if you assign this index to this variable, it just maps it. Again, to print this, it's similar to what we have done with other containers. We say iterator is equals to map dot begin and iterator not equals to map dot end plus iterator. But we have two elements here, the first and the second, similar to pair. So you could just print itr dot pointing to first, because we are having two variables here, and itr pointing to second, and a new line. So let's run this, and you can see we have 200 and then 3 200. So what that means is that itr pointing to first is the key and itr pointing to second is the value here. So that's how map works. And also, if you have the difference between a map and unordered map is that, let's say if you before 2, let's say I have given mp of 100 is 1000, and even after this if you print, then I think you must see a structure here. Even though I have assigned this to after 100, it sorted itself while printing this. So what it means is that map stores every key in a sorted way. So that might be a plus, or I mean a advantage or an disadvantage depending on the situation. But most times maps tend to have a higher time complexity because it needs to have things sorted. So to solve this, we have unordered map. So that's where unordered map comes in. So to include unordered maps, we don't do this, we just include it like this. And similar to map, we just declare unordered map of int and let's say ump, and let's do the same thing. ump of 100 is 1000 and ump of 2 is 100 and ump of 3 is 200. Let's do the same thing, and also let's print the same loop. So let's see what's the difference is. I mean, let's put a CO to differentiate these two print statements. So let's run this. The first map, everything is sorted, and the second unordered map, it's all unsorted. So that's the main difference between map and an unordered map. Next I think is the bit sets. So let's include that. So hash include bit set. So if you are performing some bit operations, usually in comparative programming we do it on a string. Like if you need a 32-bit you say zeros and ones, then we usually take a string and do it. But bitset provides a much more simpler way to do this. So let's declare that by saying bitset of number of bits you want to use. So let's say I want to use 5 bits. Let me name this bt. And if I see out this bt, so there's no iterators for this. It's quite simple. Then you can see I get 5 zeros. Actually the first 0 is from the above line somewhere here. And if I save this and run this, I should get 5 zeros. So which means all the bits, I mean all 5 of the bits are not set. So we can set that by saying bt of, let's say, 0 is equals to 1. Let's print after that. So by saying bt of 0 is equals to 1, we set the 0th, you can say here, I mean 0 starts from the right side, right? I mean it goes on like the power of 2, so it goes 0, 2, 4, 8, 16, so on. So if it's 0, then it's going to be here, right? This is the least significant bit right now and the most significant bit. So that's how it works. You could say bt of 3 is equals to 1, and then it does the same. The 4th bit is set, and there is a functionality called flip. So you could say bt of 0 dot flip. I think this should flip the 0th bit again. So we assign it to 1 and then we flip the bit. Flip means like change 1 to 0 and 0 to 1, whatever, just flip the bit. There are some other utility functions for this. There is, I think, bt dot none. Let's know this. So bt dot none, what it does is it gives you a boolean value, false or true, which means it tells if it is false, then means at least one of the bit is set. If it is true, then no bits are set. Basically what it says is that if the bits are all zeros, then it's going to give you 1. If any one of the bit is 1, then it's going to give you a 0. So right now it's giving us a 0 because this bit is set. Even if we remove these things, and we should get a 1 because no bit is set, right? So we get a 1. Even if we have some bits like 0 and 3 are set, we could do bt dot reset to reset all bits to 0, which means we should be getting 1 again, because even though we have set this, we have reset all the bits, so it sets all the bits to 0. So these are some of the C++ containers I wanted to discuss. There are still many containers in C STL, but these are like primary need to know if you're going to start with STL. Like if you know the syntax or if you understand the syntax, I think you could learn any other syntax or any other container that's in the STL library. And I think that's it for this video, and thank you for watching. I know it has been a pretty long time since I posted a video, so yeah, I'm back. So do like this video and subscribe to my channel. Thank you.